Hello class, so in this one we're going to talk about half angle and power reduction together because, as you can see them here, they are very similar. So these ones are called power reduction, these ones are called half angle. How you can tell? There's a power, it's being reduced. Hence power reduction. And then over here we have half of an angle, therefore half angle. So very creative names. Anyway, let's get into figuring them out. Again, you don't have to memorize them, although being able to recognize them is very useful, especially in calculus. So we're going to use multiple forms of cosine 2 theta for this. Which ones? Well, we're going to use those two, not cosine squared minus sine squared, but the other ones that come from it. So we're going to use cosine of 2 theta equals 1 minus 2 sine squared theta. Alright, so our goal is to isolate sine squared theta, right? So let's just get things away from it as much as possible. If we subtract 1 from both sides, we get cosine of 2 theta minus 1 equals negative 2 sine squared theta. Let's divide both sides by negative 2. So that's going to switch the signs as well. So if we do that, we get 1 minus cosine of 2 theta divided by 2 equals sine squared theta, which actually is the identity that we are looking for. So first power reduction, done. Alright, so the other one that we're going to apply for this one is just going to be the one that's not the one we already did. So cosine 2 theta equals 2 cosine squared theta minus 1. Add 1 to both sides. We get this. And then if we just divide both sides by 2, we end up with cosine squared theta equals 1 plus cosine of 2 theta divided by 2. Okay, if you want to memorize / kind of check that you are getting the correct thing, I always kind of think of it as, okay, remember cosine related stuff is going to have a positive cosine in it usually, and then sine related stuff, if there's cosine in there, is going to have minus cosine. It's just a lot of it happens to work out that way. Don't necessarily do that for all of them. I just do that for a few of them, like this one and the last one, like I mentioned. Alright, how are we going to use these to get the other ones then? So actually this isn't too difficult. So I'm just going to write down the power reduction here, and then you're probably going to be able to see where this is going. Okay, so let's do one thing first. Let theta equal theta over 2. If you do that, then we have sine squared of... So we're just going to replace all the thetas with theta over 2. We get 1 minus cosine of theta, because 2 times theta over 2 is just theta, right? Now, the thing that we need to do is just square root this. If we square root the entire thing, then what we end up with is sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta divided by 2. So we've proven that. Similar thing over here, cosine squared of theta over 2 equals 1 plus cosine theta, all divided by 2. Square root the whole thing, we get cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta divided by 2. And now we have proven all of the trigonometric identities that you're going to be using for the duration of trigonometry in pre-calculus. And any other videos on this is basically just going to be, let's practice working with them.